Hi, welcome to Sachin Study Tech. Today topic is AVL tree. So what is meant by AVL tree? AVL tree is a special kind of binary search tree. So what is meant by binary search tree? Now we can discuss what is the drawback in binary search tree. Then how can rectify the drawback by using AVL tree. So it is invented by Edelson, Wilsky and Landis. AVL in 1962. So it is called as a self-balancing. What is meant by self-balancing? So now we can discuss. Okay, this balancing ensure that operations like searching, insertion and deletion are always fast, taking only big of log n time. Now we can discuss here. You can see what is the binary search tree. Binary search tree. So binary search tree is follows. It is a binary tree. You know what is meant by binary tree? The binary tree consisting of at most two children. That means at most two children means, so for example I am consider this is a binary tree. So here you can see this is also a binary tree. This is also a binary tree. So here for example 20 and 30, this is also a binary tree. Now you can see here the node consisting of, here you can see there are three children. So for example I am taking here 1 2 3 and 4, but this tree is not a binary tree, What is meant by binary tree? The binary tree is at most two children. So here you can see only one root node is there. Here only one children is there. Only one children. Here you can see this node consisting of two children. It is also acceptable. So here you can see in this tree having more than two children. So this node consisting of more than two children, it is not a binary tree. So it is a binary. What is meant by binary tree? Okay, now what is meant by BST? Binary search tree. Now you can see what is meant by binary search tree. Binary search tree is a binary tree, okay, which is a binary tree, and also it can follow the principle all the left subtree values less than the root and all the right subtree values greater than the root. So that is right subtree values. Here you can see simple thing, what are the elements is there on left subtree, that is less than the root, and what are the elements are there in right subtree, those elements are greater than the root node. So this principle it can follow the BST. Now you can see here what is the problem in that BST. Now we can discuss. So I am consider 10, 20, 30. These are the elements. First we have to construct BST, binary search tree. So I am taking the 10 is here. Initially there is no tree, it is empty. So the 10 is the root node. I am consider this is 10 is a root node. So where you can add the 20? Here you can see all the left side values less than the root, and what are the values are there in right subtree, which are those elements are greater than the root node. Now here you can see the 20 is which is less than or greater than. Here you can see 10 less than 20. So 20 will be placed on right side, right? Here 20 will be placed here. Okay, then again if you want to insert 30, so you can compare with the root node which is greater than. So that's why here you can see here you can compare with the 20 to 30 here, which is also greater than. So 30 will be placed here. You can see this is the binary search tree. So what is the time complexity of the binary search tree? It is also called as the degenerated left queued or right queued tree. Here it is a right queued tree here, right queued tree here, and right AV tree, and also degenerated tree. So which is the time complexity? Worst case time complexity is big of n. The time complexity of BST, worst case time complexity of BST is big of n, because for example we have the three elements. So the time complexity must be measure the height of the tree. So what is the height of the tree? Here the height is here one level, here it is two level. So height of the tree is 2. So we have to take the three elements, but the time complexity is okay the height of the tree. So that is approximately big of n. So that is the problem in that. So you can see there is no balancing here, but here in AVL tree is, it is a, first of all it is BST, binary search tree, and also additional property is balance factor. Additional property is balance factor. What is meant by balance factor? Now we can discuss. The balance factor means height must be balanced. Here you can see height of the left subtree, height of the left subtree minus height of the right subtree, that is equal to 0, 1, minus 1 only. Other than that, the tree is not balanced. We have to balance the tree by using notations. Okay, now you can see the simple thing. So how can problems you can solve this? So the time complexity in this case, the BST is, the worst case time complexity is big of n, but in this AVL tree the time complexity is big of log n. Big of log n. Now you can see the notations. What are the notations you have to follow? Here these are the notations. 4 notations: left left, right right, left right, right left. Whenever the tree is not balanced, so have to perform these notations, the tree becomes balanced. So how can perform these notations? What is meant by left left, right right, like this? How to see? Here I am taking 10, 20, 30. Have to create AVL tree. Now initially I am consider it is empty. I am consider the 10 is the root node. So we have to each and every node we have to take. We have to insert each and every node to existing AVL tree. We have to calculate the balance factor. What is the balance factor? Left subtree, height of the left subtree minus height of the right subtree. It must be, okay, here you can see height of the left subtree minus height of the right subtree, that is equal to 0, 1, minus 1 only. Okay, this is the balance factor. This is balance factor equal to height of the left subtree minus height of the right subtree is equal to 0, 1, minus 1. Now here, what is the left subtree height? Here you can see there is no left subtree, right? So which is 0. So 0, here there is no right subtree for this, which is also 0. 0 minus 0 is 0. So the balance factor of 10, this particular node is 0. Now we have to add one more node. So here 10 and we have to add 20. So first of all it can follow the BST only. So 20 is greater than the 10. So the here we can add here in right side, 20 is added here. Then you have to calculate the balance factor. So the balance factor of 20 is, there is no left subtree, right? There is no right subtree. So here the balance factor is left subtree height is 0 and right subtree height is 0. So 0 minus 0 is 0 here. But in this case in 10, how there is no left subtree, the left subtree height is 0, right? Right subtree height is 1. So this is one level. So that is 1. That is equal to minus 1. It is also acceptable because here the balance factor 0, 1 and minus 1 is acceptable. So still it is a balanced. The tree is a balanced AVL tree. Now we have to add next element 30. So here 10, and you can add the 20 right of the 10, right? It can follow the BST, right? Here 30 can add right of the 20. Okay, you can follow the BST first. So here you can calculate the balance factor of this. So the balance factor of 30, here it is 0 because there is no left subtree, there is no right subtree. So that is 0. Here the balance factor of 20 is, here the left subtree is 0, right subtree is 1. So one level is there. We have to don't count the number of nodes, have to count the levels. So this is one level. So this is one level. That's why here left subtree height is 0, 0 minus 0 minus right subtree height is 1. That is equal to minus 1. Right? Here you can see. Okay, here also you can calculate the balance factor of 10, node 10. So the left subtree height is 0. Okay, right subtree height. So this is one level, this is one level, this is second level, right? So this is level 1, this is level 2. So that is 2. Height of the right subtree is 2. So that is equal to minus 2. So you can see that here the balance factor must be 0 or 1 or minus 1 only. Other than that, it is not balanced. Okay, it is not a, here you can see that here the 10, the balance factor is 2, here 20, here 20, the balance factor is minus 1. So here you can see it is 30, the balance factor is 0. But here there is no problem minus 1, here also there is no problem 0 because here it's satisfied. But in this case here you can see the balance factor of this particular 10, the balance factor is minus 2. So it is not balanced. How to perform the notations? Then the tree must converted into the balanced tree. Now here what type of notation you have to apply? So these are the 4 notations. Okay, these are the 4 notations you have. So which notation you have to apply? You can see here this is 20 is the right of 10, right? So it is right. Here the 30 is the right of 20. So here also right. So right is there. So here you can see right is there. So whenever you can see this LL and RR, it is a single rotation. Okay, it is a single rotation. Here you can see. But in this case LR or RL, right left right, in this case double rotation you have to perform. These two are double rotation, have to perform double rotations. Okay, these two are single rotation. Okay, now you can see here it is a right, so that you have to perform single rotation. Which type of rotation you have to perform? Whenever you can see the right, you have to perform the left rotation. So here you can rotate left. That means just tag the thread here, just pull down in left direction. Okay, that is left. So here you can pull down in the left direction. So here the 20 is root node now. Here the 10 is left of 20. So here the 10 is there. Here you can see here it is 30. Here it is 30, right? You can see the balance factor of 10 is 0. Here the balance factor of 30 is 0 because height of the left subtree is 0, height of the right subtree is 0. So that is 0. So here also you can see height of the left subtree, that is 1, right? Height of the right subtree, that is also 1. So 1 minus 1, that is 0. So it is balanced. It is a AVL tree. Okay. So that here the right rotation you can see. Now I am taking the elements. I am taking the elements in this direction, in this order, 30, 20, 10. So I am taking 30. So here you can see 30 is the root node. So you have to calculate the balance factor of 30. Height of the left subtree is 0. Height of the right subtree is also 0. 0 minus 0 is 0, right? Have to add 20. Where you can add 20? So which is less than here 20. So we have to add left of 30. It is 20, right? Here you can see it is 10. It is also add left of 20. It is 10. Okay, before adding this, before adding 10, have to calculate, after adding 20, have to calculate the balance factor. Here the 20 before it is 0. Okay, it is here. It is the balance factor is now you can see here it is 0, the balance factor here it is 1, and the balance factor of 30 is here it is 1 and it is level 2. The left subtree height is 2 and 2 minus here the right subtree height is 0, right? There is no nodes on right side, so it is 0. So that 2 minus 0, that is 2. Okay, in this case you can see it is minus 2. So this tree is also called as right AV tree. That means have the more number of nodes on right side, that is called as a right AV tree. Here in this case we get the positive 2 plus 2. In this case it is a left AV tree. That means more number of nodes are there in left side. Okay, this is left AV tree. Now it is not balanced because of this node here. The balance factor of 30 is 2. So you can see the balance factor must be 0, 1, minus 1. So that how to perform the operations. What type of operation you have to perform? You can see 20 is the left of 30, right? It is left. So 10 is left of 20. So LL, because of LL it is a problem. So that what type of rotation you have to apply? Just opposite. So here the left is there, you have to perform the right rotation, single rotation. You can see here the LL and RR are single rotation. LL means you have to perform the opposite, that is right rotation. RR means you have to perform left rotation, right? So here the left, that is you have to perform right rotation. Okay, just tag the thread here, pull down in right direction, in right side, right rotation. That means 30 becomes, here you can see 20 is the root node. Now 20 is the become root node. Here 30 is right of 20. So here it is 30. Here it is 10, right? It is 10. Okay, now again we have to calculate, after rotation you have to calculate the balance factor. The balance factor of here the 10 is 0, here the balance factor of 30 is 0, 20, the balance factor of 20, that means left subtree height is 1 and right subtree height is 1. So 1 minus 1, that is also 0. So it is balanced. So these are the single rotations, LL and RR. Okay, now how to discuss, right? Already, so this is the problem here. Here the 10, here it is 20. Now we can see here it is 30. So this is right. We have to perform the left rotation, right? Have to, after performing left rotation, the tree is balanced. Here you can see, here it is 10, it is 30, right? Here before doing this rotation we have to calculate the balance factor. It is 0. The balance factor of 20 is minus 1. The balance factor of 10 is minus 2. It is not balanced. We have to perform RR. That means left rotation. That means left rotation. Left rotation you have to perform. So here you can perform the rotation, left rotation. After performing left rotation, you can check the balance factor. It is 0, it is 0, it is, the balance factor is 0. Now here you can see I am adding 30. I am taking the numbers like this. Okay, 30, 20 and 10. In this case 10, 20, 30. Okay, now 20 is less than 30. That's why here you can add 20 here. You can add 10 here. 10 here. The balance factor of 10 is 0. The balance factor of 20 is 1. The balance factor of 30 is 2. Right? It is not balanced because of left. Have to perform the right rotation. Okay. So here see. So the problem is left. So we have to perform the right rotation. So that, okay, we have to pull down here in the right direction 30. So 30 becomes right of 20, here the 30, then 10, here it is, which is the balance factor is 0, here the balance factor is 0, here the balance factor is 0. Now how to discuss, here I am taking the numbers 10, 30, 20 in this order. Now here the 10 is the root node, the balance factor of 10 is 0. Okay, after here you can take 10, you can add the 30 because already it is balanced, we have to add the 30. Now I am adding the 30 here. So after adding 30 you have to calculate the balance factor, it is 0, the balance factor of 10 is okay minus 1. Then you have to add the 20 here, like that step by step we have to calculate the balance factor. If it is satisfied, then you have to add the next node. Then here you can see it is balanced, then you have to add the 20, where you can add the 20. Now you can see it is 30, the 20 is less than 30, that's why you can add 20 here. The searching operation is performed, right? Here this is. Now you can see after adding this, the balance factor of 20 is 0, the balance factor of 30 is 1 because left subtree it is 1, right subtree is 0. Now you can see the balance factor of 10 is, the node 10 is, there is no left subtree, so that is 0, and right subtree it is 2. Okay, that is minus 2. 0 minus 2, that is minus 2. So it is not balanced. So what is the problem here? What notation you have to perform? So here it is right, 30 is right of 10. Okay, so 20 is left of 30. Here you can see RL. So here it is, the problem is RL. Because of RL it is not balanced. Okay, so that we have to perform, here the L is there, left is there, so that we have to perform opposite. So here L is there left, so we have to perform the right rotation. Okay, where you can perform the right rotation? So you can see in this subtree only have to perform the right rotation. So right rotation means we have to pull down 30, tag the thread here, just pull down in right direction. That means here 30, and whenever you can pull down in the right direction 30, so the 20 becomes the parent of 30, right? Here the 20, and now it is 30. Okay, now you can see after performing right rotation, right rotation, so here you can see it is right. How to perform the single left rotation, still it is not balanced. Okay, you have to perform the left rotation, so that RL or LR is, we have to perform double rotations. Okay, LL and RR are single rotation. Now we have to perform the left rotation. You can see just right is there, I have to perform the left rotation. So that is in left direction, here the 20 becomes the root, here the left of 20 is 10, here the right is 30. So you have to calculate the balance factor, here it is 0, here it is 0. Okay, it is balanced. Now you can see here in this case I am taking 30. Okay, in this case what the problem here, it is RL, right? Here you can see RR, here you can see LL. So one more notation you have to discuss, so that is LR. Okay, so that how to take the elements 30, 10, 20. For example, I am consider in this order, so 30 becomes the root. Okay, the balance factor of 30 is 0. Then you have to add the 10, where you can add, so 10 it can follow the BST, right? So 10 will be added here in left of 30. So it is 0, it is 0 balance factor, sorry, it is not 0. In this case it is 0, right? So there is no left subtree, there is no right subtree. So 0 minus 0 is 0, but in this case we have the one left subtree, height of the left subtree is 1 and there is no right subtree. That means here the balance factor of 30 is 1. Okay, it is balanced. Now we have to add next node 20. So here where you can add 20. So in this case 10 is there, where you can add 20, the 20 will be added here because you know BST it can follow. Okay, now you can see the balance factor of 20 is 0, right? The balance factor of 10, there is no left subtree, so 0. Right subtree height is 1, so that here left subtree height of the left subtree minus height of the right subtree, so that is minus 1. Right here height of the right subtree is 0, left subtree height is 2, right? This is one level, this is second level, so that it is 2. So it is not balanced because of it is left and right. Here you can see left of 30 is 10, right? Here 20, right of 10 is 20, so that LR, so that here LR how to perform, you can see that it is a double rotation we have to perform. Okay, this is 10 and 20, so it is right, right? So we have to perform the left rotation, just opposite. Here R is there, have to perform the opposite rotation, that is left rotation. After performing left rotation, have to see, so pull down in the left direction, the 20 becomes here, the 20 is there here and 10. Okay, now we can see it is left left. Again you can see here in this left left, so we have to perform right rotation, right? Still it is not balanced. You can see the balance factor of 10 is 0, the balance factor of 20 is 1, the balance factor of 30 is 2, so that we have to perform right rotation. That means whenever you can tag the thread here, just pull down in this direction, right direction, the 20 becomes the root here. Okay, just here it is 30, here it is 10. Okay, so that here the balance factor of 10 is 0, the balance factor of 30 is 0, the balance factor of 20 is 0. Height of the left subtree, that is 1, height of the right subtree, that is 1, 1 minus 1, that is 0. So these are the 4 notations. Okay, so have to perform 4 notations, then it is balanced. Now you can see here, in this case, what is the drawback in BST? The BST is the time complexity is big of n, but in this case here, so it is not balanced, it is not a AVL tree. Okay, then have to perform the rotation, then the tree becomes the balanced now. Okay, here you can see the balance, so height of the, so that's why it is big of log n, the time complexity is big of log n. For example, how many number of, here the log n means, here the log n means how many number of nodes is there? 3 nodes. So big of log 3. Okay, that is 1 point something. So but here in this case the time complexity is log 3. Okay, so that is the time complexity is big of log n. Simply the time complexity of AVL tree in all cases, that is best. Okay, in worst case and average case also the time complexity is big of log n. Okay, later classes we have to discuss how to add the nodes to the AVL tree, how to create AVL tree, and how can perform operations on delete operations on AVL tree. Later classes we are discussed. Thank you for watching this video. Thank you for watching. Please like, subscribe and click the bell icon for the latest notifications.